Welcome everyone. My name is Saurav Sarma, and in this lecture we will discuss about the concept of correlation and regression. Now so far in all our statistical theories that we have discussed till now, like mean, median, mode, standard deviation, range or mean deviation, or even when we are plotting them in case of data grouped in frequencies, discrete or continuous, everywhere we were so far discussing about only one characteristics at a time, right? So either we were exploring the height or weight or marks of student, etc., etc. So every time we are only focusing on only a single characteristics. Now what if a situation arises where we want to study or we want to focus simultaneously in two different characteristics of the same item, right? Or for the same individual or for the same item, we want to focus on two different characteristics simultaneously, right? By the way, from now on, characteristics will be defined or we will mention characteristics as variables. Now just brief idea about what is variable. Variable means something that changes its value, right? So humans age keep on change constantly, right? Our weight also changes, our height also changes, our blood pressure, blood sugar, oxygen level, everything keep on changing over time, right? So anything that changes over time is called a variable, or anything that we are interested in studying will also be called a variable, right? So if you are interested in knowing the salary of a person or salary of a group of person, salary changes from person to person, right? So in that case, salary or monthly income will be a variable, right? So what is bivariate data? When we consider two characteristics simultaneously, then such data is called bivariate data. So for example, if we consider both height and weight of a group, then such a data will be called a bivariate data of height and group. Similarly, if I consider salary and expenditure of employees, then that will constitute a bivariate data. Similarly, if you simultaneously measure the blood pressure and blood sugar of patients, then that will give you a bivariate data. Now if you extend this to mode, let's say you are considering three different variables at the same time, that is called trivariate. And if you consider multiple different variables simultaneously, that will be called multivariate data. But we will not go to multivariate or trivariate data. For now, we will simply stick to bivariate data. That means we are only considering two characteristics at a time. So to understand the formula of correlation and regression, we need the knowledge of another formula which is called covariance. Right? So what is covariance? Covariance measures the simultaneous variation between two variables, right? Or characteristics. How two characters vary simultaneously is measured by covariance. So let's say, for example, now one thing that you should always remember, what is variance? Variance measures the amount of variation or fluctuation in a characteristics or a variable, right? So let's say there is a variable called x which changes from -3 to +3. That means the value of x fluctuates between this value, right? It can be -3 sometimes, it can be anything between this range, right? -3 to 3. Okay, and there is another variable called y which changes between -10 to +10, suppose. Okay, now if these negative terms are confusing, we can further simplify it. Let's say that one variable called x changes, or it has the variation between 0 to 10. There is something, a variable or characteristics that we are interested in, which can take anything between 0 and 10. And there is another variable which can take values from 0 to 5, right? So this 0 to 5, this is the range of y. This 0 to 10 is the range of x, right? So if you calculate the variation of x, you will get a value. If I calculate the variance, and if I calculate the variance of y, I will get a value anything between 0 and 5, anything between 0 and 10. So now if I simultaneously consider these two values, there will be a amount of variation. That means if I take or if I consider both of them at the same time, their range of variation may be completely different. That may be 2 to 5. The together x and y may vary only between 2 to 5. Okay, so that is called covariance. So covariance measures the amount of variation when two things considered together varies, right? And it is measured by this formula. So originally the formula is this. The only thing different is in case of variance, it is 1 by n summation xi minus x bar whole square, right? In case of variance, we consider the square. Now the only thing different is instead of taking 2 xi minus x bar, we have split it as 1 xi, 1 for x, 1 for y. That's the difference between a formula for variance and a formula for covariance. Just like in case of variance, where we have simplified the formula so that calculations are easier, in case of covariance also we can simplify the formula to write it like this: 1 by n summation xi. So basically what we have to do in case if we want to calculate covariance, first you will have to find out x bar, then you will have to find out y bar, then you will have to find out the product of x and y, then add them, divided by n. This value minus the product of these two value will give you the covariance. So this is a preliminary knowledge that you need to understand covariance. Okay, correlation. So what is correlation actually? So correlation is a statistical technique which measures the degree or amount of association or an amount of relationship between two variables, right? The degree to which two variables vary with reference to each other. Okay, so if change in one characteristic or variable will be same. So if change in one variable or characteristic bring any change in the other, then the two variables or characteristics are called correlated. So suppose there are two variables, one is let's say height and one is suppose weight. So this is one variable or characteristics height, one is weight, right? Now if the height of a person change from let's say 5 feet to 5.2 feet, right? If the height of a person change from 5 feet to 5.2 feet, will the weight also change, right? If the weight also change with the change in height, then we say that these two has some kind of relationship between them, right? They are bonded, right? That relationship is measured using correlation. Okay, so correlation is a statistical technique or formula to measure the amount of association or relationship between two variables. If changing one variable also changes the other variable, then they are called correlated. On the other hand, if change in one variable does not impact anything or it does not bring any change in the other variable, then the two variables are called uncorrelated. So what are the two new terms? One is correlated, one is uncorrelated, right? Correlated is when one impact the other. Uncorrelated is when these two does not impact each other, right? Now how we can measure this correlation or this degree of association or the amount of correlation between two? The amount of correlation is measured using the formula called coefficient of correlation. Now this was given by Carl Pearson. So Carl Pearson is a statistician who developed this formula for correlation, right? The formula to measure correlation. That's why it is in most of the book it will be referred as Carl Pearson's coefficient of correlation. So whenever you see Carl, say for example in an examination you got the question is measured Carl Pearson's coefficient of correlation, or whenever you are using any statistical tools they will also give you this name Carl Pearson's or Pearson's correlation coefficient, right? So this is a formula to measure the amount of correlation. Now what is the formula? The formula is simple. If you have two variables x and y, then to find out the coefficient or the correlation between these two, we use the formula Rxy. Now this is called, Rxy is called the coefficient of correlation between the variables x and y, right? Now don't replace this r by capital R. This is not correct. We always use small r. Okay, so small r xy is given by covariance between xy divided by SDX, means standard deviation f, and standard deviation of y. Now this can also be written as covariance xy sigma x and sigma y, if you are comfortable with the sigma symbol. This is the same formula. So on numerator you will get covariance, on denominator you will get the product of the two standard deviations. The formula can be expanded like this. On top we have 1 by n summation xi yi minus x bar y bar. Now I have already told how to calculate covariance, and we have already done examples of calculating standard deviation, right? So if we combine all this formula together, we get a new value which we call the coefficient of correlation, right? Now this coefficient of correlation has certain properties. There are some points that you should remember about this coefficient of correlation. The first one, and which is the most important one, and I am repeating is this again and again, this point is the most important one. Why? Because in most of the calculations, manual calculations, if you are calculating this correlation manually from a data set, most people do some kind of mistakes. Now if you are going to verify whether you are doing the calculation right or wrong, this will help you. Why? This states that the value of correlation coefficient or coefficient of correlation lies between minus and 1. That means the lowest, this Rxy, the lowest value it can go is minus 1, and the highest value it can go is plus 1. So in a calculation, if you find out Rxy, you got the value as, say, suppose 1.5. That means somewhere in your calculation you have done some mistake, right? So this is a good way to verify whether your calculations is correct or not. Fine. So this is your first point about the coefficient of correlation or R correlation. The next point is, if the value of R, now if R is less than 0, that means it is negative. Let's say for example R is minus 0.7, right? If you get the value of correlation coefficient as a negative value, then the correlation between the two variable x and y is called negative correlation. It is called negative correlation, or we say that the two variables are negatively related. That is the same way of stating the same fact, right? Now if this rxy is greater than 0, that means if the value is positive, let's say for example r is equal to, let's say 0.5, that means the two variable x and y are positive correlated. The correlation between x and y is positive, or we also call it positively correlated, right? They are the same thing, right? Now in case in some example you found out that correlation, this coefficient correlation, this formula gives you a value of 0. Now if it is 0, then x and y are called uncorrelated. We use the word uncorrelated or not statistically related. They are the same thing. So we will say that these two variables are uncorrelated when the value of r is 0, right? So first point is the value always lies between -1 and 1. Second point, if it is negative, then the correlation is called negative correlation. If it is positive, then the correlation is called positive correlation. If it is 0, then the correlation is called uncorrelated, or we say that there is no correlation. Now the last point is rxy is same as ryx. If you interchange x and y, the value will not change, right? So correlation coefficient between x and y and correlation coefficient between y and x are the same thing. Okay, that's next point. Now if your value r, there are two special cases. If your rxy, the correlation coefficient is exactly equal to -1, that is if rxy or even ryx is -1, then it is called perfect negative correlation. And what is the meaning of perfect negative correlation? Perfect negative correlation means then every unit, let me remove this. Okay. So what is the meaning of perfect negative correlation? Every unit increase in x results in an equal decrease in y. So negative correlation means, so let's understand the concept of positive and negative correlation in a better way, right? So let me draw a diagram. Okay, along x-axis we are plotting a variable, along y-axis we are plotting a variable. Now if I get a line like this, if I plot these two data and I got a line like this, then this means that whenever x goes from, say suppose 1 to 2, y also goes from, say suppose 5 to 10, right? Initially when x is equal to, here let's say it is 5, and then this is 8, this is 10. Okay, so whenever x goes from 1 to 2, the y value is 5, it goes from 5 to say 8, right? 5 to 8. That means when x increases, y value is also increasing, right? So that is called positive correlation. That means increase in one variable also increase the other variable, right? So this is positive correlation. Now if we plot a diagram like this, right, in this case this is suppose x, this is suppose y, and let's say this is 1, this is 2, this is 3, and this is 5. This value is suppose 4, this value 3 to 1. So when x is equal to 1, y was equal to 4, right? x equal to 1, y equal to 4. When x increases to 2, right, when x increases to 2, y becomes 3. When x increases, let's say the diagram is like this. So when x is equal to 3, y is equal to 2. So see the pattern. When x is increasing, right, from 1 to 2 to 3, y on the other hand is decreasing. 1 is increasing, x is increasing, y is decreasing. So that is called negative correlation. When positive change in one reflects a negative change in the other. In this case, positive change in one also reflect a positive change in the other one. So that is called positive correlation and negative correlation. Let us take another example to explain this concept of correlation, either positive or negative. So let us consider that we have a bowl or a container where we have a liquid up to this mark, right? The container is filled up to this mark initially, right? This is suppose the height up to which the container is filled is 5 centimeter, and we have marked at every centimeter, right? So 1 centimeter, this will be 6 centimeter, this will be 7, this is 8, 9, 10. And every time there are certain cubes of same weight or same mass, right? So every time I drop this cube to this container, if I drop 1 cube to this container, the level of this liquid rises by 2 centimeter. Right? This cube rises by 2 centimeter. This cube is, suppose we are changing or we are dropping 1 cube at a time. If I drop another cube, this will increase to 9, right? This level increases to 9. Now if I drop another cube, this will go to 11 centimeter, right? So every change in 1 cube, so whenever I change 1 cube or I drop 1 cube, there is an equal amount of 2 centimeter rise in the level of liquid, right? So that is called perfect positive correlation, right? Every increase in 1 increase, that means from 0 we go to 1, from 1 to we go to 2 cubes, from 2 cubes we go to 3 cubes. So it means the change in here is 1, right? Only 1. But in case of liquid, it is from 5 we go to 7, from 7 we go to 9, from 9 we go to 11. So here the change is 2 centimeter. So every unit change in number of cubes gives us a equal amount of 2 centimeter change in the volume of liquid, right? So that is called perfect positive correlation, right? Now in another situation, if you have a certain variable called x and a certain variable called y, right? So every time this x, let's say the first value of x is 5, from 5 this changes to 6, then 7, then 8. So when x was 5, the value of y was suppose 100, right? When it goes from 5 to 6, the value of this changes to 90. When it is 7, it goes to 80. When it is 8, it goes to 70, right? So every time x change with a value of 1 unit, right? 5 to 6, 6 to 7, 1 unit, 7 to 1 unit. The value of y is changing by 10 unit. Every time it is 10 unit, and the change is negative, right? Because it is decreasing. So whenever x goes 1 unit up, the corresponding value of y goes 10 unit down. 1 unit up, 10 unit down. But the decrease is similar, right? When they consistent decrease. So that will be called perfect negative correlation. So this Rxy equal to -1 does not mean that whenever x grows from 5 to 6, y will go from 100 to 99. It is not equal amount of change. It is mean equal proportion of change, right? That means 1:10 change is happening in this example. This is 1:2 change is happening in this example, right? So that is called perfect positive correlation and perfect negative correlation. Okay. Now let us try an example to have a better idea how to calculate correlation. Right? So we have our example number 1, which states certain values of age. That means these are the values, or these are the amount of blood sugar experienced by a single person over different ages, 23 to 28. The blood sugars at 23 years was 87, and by that time this person reached the age 28, the blood sugar increases to 102. And we want to see, or we want to calculate the amount of correlation between the age of the person and blood sugar of that person, right? Okay, so I have entered the data, that means age and blood sugar, in a spreadsheet. Here I am using LibreOffice Calc. You can use Excel also, or you can use the online Google Sheet. It does not matter, everything is same. So I am taking help of this spreadsheet application so that the calculations will be faster, right? So we have two different data. One is age, one is blood sugar. We have marked age as X and we have marked blood sugar as Y, right? So we have to calculate correlation, and to calculate correlation, the formula is, here is the formula, right? Covariance of XY divided by standard deviation of X and standard deviation of Y, and we will be using this formula, right? So let me write down the formula. So the formula is R xy is equal to 1 by n summation xy minus x bar y bar. And what is standard deviation? Standard deviation is 1 by n summation x square minus x bar square and 1 by n summation y square minus y bar square. Now one thing here that I would like to add, unlike in case of median or standard deviation or mean, where we also deal with frequencies, that means we have formulas for standard deviation when we have frequency data. In case of correlation, we does not consider frequency, right? So correlations are not calculated for grouped data. They are always calculated for ungrouped data, right? So that's why this is the only formula. You don't add fi here, or you don't add fi here in correlation formula, right? So this is the formula. So what are the different steps? The first step is obviously you will have to calculate this x bar and y bar. Step number 1 is calculate x bar and y bar. Step number 2 is we need x square, y square and xy, right? So calculate x square, y square and xy, right? Step number 4 is find out the sum of these columns, y square and summation xy. Once we get this x square, y square and sum of xy, we can then fill these formulas or these different parts to get the correlation, right? So that means we need the arithmetic means, we need x square, y square and xy, right? So let's get back to this spreadsheet application. So we will calculate 3 new columns, right? One is x square, one is y square and one is xy. That's all. We don't need anything else. We only need these 3 columns. Okay. So for these 3 columns, let's first calculate x square. That means this 23 square. So value is 529. Now if you simply double click here, it will automatically do. So you can copy it here. Okay, sorry. Okay, this copy. Now this is 87 square. Now if you double click, it will auto complete. And last we need x into y. Right? So if someone is not comfortable with this kind of softwares or spreadsheet applications, you can calculate them manually also. Simply square this 23 square will be here, 24 square, 25 square, 26 square, 27 square and 28 square here. Here it is 87 square, 92 square, etc, etc. So these are your x square, y square and xy, right? Now we need the total of these columns. So we will calculate the total of this, that is 3919. So basically this value, this 3919 is summation x square. So we got summation x square is equal to 3919. We got summation y square is equal to 53912 and summation xy is equal to 14533, right? So we need 2 things more, which are we need summation x and summation y. So you can simply copy this here. So this is the summation of x, that means sum of 23 up to 28. This is summation of y. Right? So we got summation x equal to 153. Summation y is equal to 568. So we got all the values here. So next term that we need to calculate from this is obviously the average, right? X bar. Now what is x bar? X bar is summation x divided by n. Now what is n? N in this case is the number of items, that is 1, 2, 3, 4, 5, 6. So we have 6 items and that is n. So n is equal to 6. So what is x bar? X bar is 153 divided by 6. That will be x bar. Similarly, what is y bar? Y bar is, this is the total of y. So 568 divided by 6, right? That is y bar. So let's calculate this here. This 153 divided by 6. So 25.5. This is equal to 568 divided by 6, which is 94.66. We can round it off to 94.67. So that means we got x bar as 25.5 and y bar as 94.67. So our first step is done. Okay, so we have done our first step, that is x bar. We calculated x bar as 25.5. We calculated y bar as 94.6. Next we have to calculate this covariance and standard deviations, right? So to calculate standard deviation, first we calculate variance. Okay, so let me write down in a new page. So variance of x is 1 by n summation x square minus x bar whole square. Now in our example, n is 6 and x square we got as 3919, right? Minus x bar we got as 25.5, this whole square. Now if you calculate this here, it will be this 3919 divided by 6 minus within bracket this 25.5 square. So this gives you 2.9166. So we got 2.9167, say, right? So that is variance of x. So what will be standard deviation f, which is also denoted by sigma x as root over 2.9167, which is equal to root over is sqrt, the function is sqrt, click this, so you will get 1.7078. This is the standard deviation of x, right? Now let's calculate standard deviation of y, or first variance of y. Now variance of y will be given by 1 by n summation y square minus y bar whole square. So n is obviously 6, summation y square is this value 53912, 53912 minus y bar we got as 94.67 square, which is equal to, so we can calculate here, this 5391 divided by 6 minus 96 square, and it gives us 23.55 or 23.56. This is 23 point, let's give 4 decimals, 5556. Okay, that is variance of y. So the corresponding standard deviation of y will be root over 23.5556, which is equal to square root of this, which is 4.8534. 4.8534. So we got standard deviation of x, standard deviation of y. Next thing is to calculate covariance of x comma y. Now what is the formula to find out covariance? 1 by n summation xy minus x bar minus into y bar. This is equal to n is 6 into summation x1 is 14533 minus x bar is 25.5, y bar is 94.67, right? So this is equal to, now I am rounding off this 94.6667. so if you calculate this manually, you may get slightly different value in decimals. That's okay. So covariance we will get as this divided by 6 minus 25 into this, right? So covariance is 8.1667, right? This is covariance. So we got covariance, so covariance is 8.1667. We got standard deviation sigma x as this, right? and we got standard deviation of y as 4.85. Let me write down this. So we have sigma x is equal to 1.7078. We have sigma y is equal to 4.8534, and we have covariance xy as 8.1667, right? So now we can easily calculate the correlation coefficient, right? Rxy, which is covariance x comma y sigma x sigma y, right? Which is equal to 8.1667 divided by 1.7078 into 4.8534. Now this gives us, let's calculate, this is equal to this divided by this into this, right? So the value is 0.9853. Now correlation normally are presented in two decimal values, so we round it off this to 0.98, right? So the correlation between age and blood sugar is found out to be 0.9852, or approximately 0.98. That means the correlation between age and blood pressure or blood sugar, is positive, right? And since this value is very close to 1, now there is a rule to interpret the different values of correlation. So let me explain that. So let me draw a line, okay? This line goes from -1 to 1, and in the middle we have 0. So let me divide these lines into certain groups. This is 0.3 minus 0.7. Similarly, this is 0.3 and 0.7. Now there is no hard and fast rule, but these are the rules that social scientists normally use, or many statistical tools also use, right? Now there are also different tests which we will go on later on, but this is a very simple way to interpret your correlation. Now, and if the correlation lies here, that means no correlation, right? So R equal to 0 means no correlation. If it is this, that is perfect negative correlation, and it is equal to 1, then it is called perfect positive correlation. But if the value is between these two values actually, -1 and -0.7, then it is called high negative correlation. By the way, there is no theory to define this. This is just being used in the field, in applied field, that I have seen that any value between -1 and -0.7 is marked as high negative correlation. This is the moderate line or moderate region, moderate negative correlation, and this is called the weak negative correlation. Similarly, any value between 0 and 0.3 is called weak positive correlation. Any value between 0.3 and 0.7 is called moderate positive correlation, and this is called high positive correlation, right? 0.7 up to 0.1 or 1. This is high, this is moderate, and this is weak. This is weak, moderate, and high, right? This is a rule of thumb that people use while interpreting correlation. So in our case, correlation is found out to be 0.98, which is extremely equal to or extremely near 1, right? So we have a very perfect correlation or approximately perfect positive correlation between age and blood sugar in this example, right? So let's get back to this example number 2. In this example, we have two variables, one is x, one is y, and we have 5 values for both of them. Now in this example, we will use the shortcut method that we have already used in case of mean and standard deviation, right? What was the shortcut method? We create a new variable d x minus a by h, right? We create a new variable d by subtracting a value and dividing by a constant value. Now here is a interesting thing. In case of mean, right, the mean of this new data, right, is related to the mean of the original data as a plus h times of d, right? This is the relationship between original data set and the data set you have created in case of mean. In case of standard deviation or in case of variance of x was h square variance of this d, right? There was no a. The value a vanishes in case of variance. In case of correlation, the interesting thing is, in case of correlation between this xy, so in case of correlation, what happens is that in case of mean and standard deviation, we used to have only one data. That's why we used to create only one new variable d. In case of correlation, we have two variables. That's why we create two new variables u and v, right? U will be x minus a by h. V will be y minus b by k, suppose. And the interesting thing is this rxy is exactly equal to ruv. There is no modification required at the end. If you calculate the correlation of these new variables u and v, you will ultimately get the same value as the original data. That is, now this property is called coefficient of correlation is independent of change of scale and origin, right? So there are three formulas that we have discussed which we calculate using this method, shortcut method. One is arithmetic mean, one is variance, and one is this correlation, right? And every formula reacts differently to this shortcut method. That's why students get confused. So you will have to make a clear, or you have to have a clear view of this, right? First one is arithmetic mean. It is dependent on both, right? It requires both a and h, right? Not independent of origin, not independent of scale. Fine. Variance, it vanishes the a terms, right? A was for origin. So variance is independent of origin. Variance is independent of origin, Arithmetic mean is not independent of origin, not independent of scale. And lastly, correlation is independent of both of them. So every formula reacts differently to this shortcut method. Okay, so basically we create a new variable and calculate the correlation for these two new variables, and the final result will be the same. So let's get back to the data. So here I have entered the data x and y, right? Now we will create two new variables called u and v, right? How we create these new variables? We subtract something and we divide by a common value, right? There is a common value and we divide it by it. So see, in this case, in case of x, the values are in an increasing manner, right? 16, 20, 24, 28, 32. So it is increasing. And a common thing between them is all of them is divisible by 4. All these numbers are divisible by 4, right? And in case your numbers are in a serial manner, that is, it is in ascending order, we normally take the middlemost value as a, right? So let me create a new page and side by side. So in this example, we will create u by taking the formula x minus 24 divided by the common number that, or the common gap, that is 4. That will be the formula. Okay. And in case of y, the values are 30, 40, 25, 35, 45. Okay. So if you arrange these numbers in an ascending order, the numbers are actually 25, we have 30, we have 35, we have 40, and we have 45. Okay. This is the actual order of these 5 numbers. So here also the numbers have a common gap, that is 5, right? All of them are divisible by 5 and the middlemost value is 35. So here we will create a new variable v using the formula y minus 35 divided by 5. So u is x minus 24 by 4, v is y minus 35 by 5. So let me calculate this. So this is divided by, so x minus 24, right? X minus 24 divided by 4. So these are the values, and in case of v, this is equal to y minus 35, this whole thing divided by 5, right? So these are the values of our new variables u and v, right? We have created two new variables u and v. Now we simply calculate the correlation. Forget about these two variables and focus on only these two variables u and v. We will only focus on these two variables, right? And we will calculate the correlation between these two variables u and v. Now the formula to calculate correlation is you need u square, you need v square, and you need uv, because we have changed x and y with u and v, right? So the formula will be now r uv is equal to covariance uv, standard deviation of u, standard deviation of v. That is what we have to calculate now. What will be the covariance? Covariance will be 1 by n summation uv minus u bar and v bar. What is standard deviation? 1 by n summation u square minus u bar whole square, 1 by n summation v square minus v bar whole square. This is the formula that ultimately we have to calculate. Okay, so we calculate u square. U square is nothing but this to the power 2. Okay, minus 2 square 4, minus 1 square 1, 0 square 0, 1 square 1, 2 square 4. Now this is equal to this square minus 1 square. This is the value, and last we have to multiply this by this. So minus 2 minus 1 2, these are the value, and we need the total of all of them, right? We sum them. So this, if I add, total of u is 0, total of v is again 0, u square is 10, v square is 10, uv is 5. Now in this example, the values are such that we got the new kind of value in a very easy way, right? This new data that we have created reduces our calculation so much that we don't even have to calculate certain values. If you know the total of a variable or total of a data set is 0, then obviously the average is 0, because u bar is given by summation u by n. If summation u is 0, then obviously the term is 0. Similarly, v bar is summation v by n. It is also 0. Now once this u bar and v bar are 0, that means we don't have to calculate this term. We don't have to calculate this term. We don't have to calculate this term. So that calculations is reduced to a great extent, right? So let's calculate the remaining. So R uv is equal to, what is n? N is the number of items. In this case we have 5 items, right? So n will be 5. So 1 by 5 into summation uv. Summation uv, these are the summations, right? These are the summation. So what is summation uv? 5. So 5. Now we need standard deviation. So root over 1 by 5, because n, into summation u square. What is summation u square? That is 10, right? And similarly 1 by 5, what is summation v square? That is also 10. So this 5 and this 5 got cancelled, so we will remain with n. This 5 and 10 will give you 2. This 5 and 10 will give you 2. So if we calculate, then we got R uv is equal to 1 root over 2 root over 2. Now what is root over 2 multiplied by root over 2? This will give you 2. That means 2, and R is 0.5. So we got our correlation as 0.5. So that's how we calculate correlation using the shortcut method. You have seen the shortcut method reduces your calculation very much. Now you will not be that much lucky every time, which will give you a total of 0, but it will anyway reduce the calculation. So I suggest you apply the shortcut method in this example also, and try to find out what will be the correlation. And if you get the exactly same correlation as we have calculated using the manual method, then obviously your calculations are correct, right? So now that we are familiar with the concept of correlation and we know how to calculate the coefficient of correlation, the next topic is called regression. Now regression takes the concept of correlation one step further. If we know that in our example number 1 we dealt with age and blood sugar, right? We calculated the correlation between age and blood sugar, and we find out that the correlation is Rxy is 0.98. That means we know that there is a high correlation between age and blood sugar for this particular patient, right? So in such a case, we can extend this knowledge, or you can utilize this knowledge for future, right? So in that example, we have data from 23 up to 28. Now suppose this person whose age and blood sugar data are available for such a range wants to know what will be his or her blood sugar at the age of suppose 35. What will be my blood sugar at the age 35, right? I want to know. And this person has not attained the age yet, right? He or she is, let's say, 30-year-olds now, and he or she wants to know what will be his or her blood sugar level at the age of 35. So how we can achieve or how we can predict this value? We use regression. So regression, it is used to predict the value of one variable from a given value of another variable, provided there exists a correlation between the two variables. So regression is only applicable when there exists a correlation between the two variables. Okay. So regression has two formulas. These formula are called lines of regression. Okay, what is a line of regression? A regression line gives the best estimate of one variable for any specific value of the other variable. Now best estimate, you should emphasize on this word best estimate, because if you interchange these two formulas, you lose this property called best estimate. So that means we have two formula. This is one formula and this is one formula. This formula, the first formula, is called regression line of y on x, and this formula is called regression line of x on y. And the question is why we need two formula. In case of correlation, we only had one formula to calculate the correlation between two variables. Now why we need two formula to calculate regression? Because these formulas are so obtained that they gives us the best estimate, right? They are derived in such a way that they can give you the best estimate or the best prediction possible. That's why to estimate x we need a different formula. To get the best prediction about y we need a different formula, right? So that is regression line of x on y. Now what is the formula? Y minus y bar is equal to byx. This byx is called regression coefficient. Just like correlation coefficient, this byx is called regression coefficient of y on x. Now what is y on x and x on y means? What is the meaning of x on y and y on x, right? So x on y means, so there are certain terms which are silent in this word. In case of y on x, the actual or the full form is y is dependent on x, right? And in short it is called y on x. Is dependent is normally silent. Similarly, x on y means x is dependent on y. That's the meaning of x on y. So that means there are two terms, y and x. One will be independent, one will be dependent. The item that you want to predict will always be dependent. The item with the help of which you want to predict will always be called independent. So let's say you want to predict age based on their blood sugar level. You want to predict this, then age will be dependent, blood sugar will be independent. If you want to predict blood sugar based on age, if you want to predict this one, this will be dependent and age will be independent. And accordingly, you will have to choose a correct formula for your calculation, right? Now what is the value of this regression coefficient? The regression coefficient is given by covariance xy divided by sigma x square for regression coefficient y on x. Now how to remember this? So first one is regression coefficient of y on x. It is written as byx. So the term that comes first in that formula, y on x, will always appear first, byx. This is equal to covariance xy divided by variance divided by variance of this independent variable. Independent variable in this case is x. So remember it like this: regression coefficient is equal to covariance divided by variance of independent, right? Covariance divided by variance of independent. Regression coefficient of y on x, in this case y is dependent, x is independent. That's why byx equal to covariance divided by variance of the independent variable, that is x. Now this can also be written as r sigma y by sigma x. In some book or in most of the book, you will get coefficient of regression or regression coefficient written as this, r sigma y sigma x, right? This, if you simplify, gives you covariance divided by variance. Now this formula is more appropriate or more helpful in calculation because we always calculate variance, then we calculate standard deviation. So that means we readily have the value of variance. Here you have to calculate the correlation, then you have to multiply by this fraction. So it requires 3 steps, this will require 2 steps, so this will reduce amount of calculation, right? Similarly, regression coefficient of x on y is written by b. The dependent is x, so it will appear first. The independent is y, so it will appear later, is equal to covariance x comma y divided by variance of the independent. So in this case independent is y, so variance of y. This is how you memorize this formula. And to memorize this entire formula, you memorize it in parts. So this is regression line of y on x. So as I have already told, when you are writing regression line of y on x, since in this sentence y appears first, so in the entire formula y will appear first everywhere. See, if you go from left to right, y appeared first, then x appeared, right? So you write first y equal sign x. You subtract the mean, respective mean from both of them. Now the formula is y on x, that's why y is appearing to our left, x is appearing to our right, right? And to our right we multiply by the regression coefficient. Now the formula is for y on x, so that's why y will appear first, x will appear later. So y minus y bar byx, x minus x bar. That is how we memorize the formula. So what will be for x, the regression line or the formula to find out x from y? Regression line of x on y. X appear first, y appear later. That's why we will write x, we will then write y. We will have a equal sign, respective arithmetic mean. You cannot mix maths, that means it is not x minus y bar. It is always x minus x bar, y minus y bar. And to our right hand side, we write the regression coefficient. Now x appear first, so x, y, right? So that is the regression line of x on y, and then we also have regression line of y on x. So these two are the formula that you have to memorize to fit a regression. Now let's revisit the same example, that means example 1, and in this case we already know that these two data, that means age and blood sugar, has a correlation. So we want to estimate blood sugar for the age 35, right? So we already know for this data set the correlation is 0.98. This one was covariance. Covariance was 8.16. This one was variance, right? Variance of y, and this one was variance of x. So we have variance of x, this is standard deviation of x. So we have all the data already calculated. Now we will use regression. So what we have to find out? We have to find out blood sugar from the value of age, right? So we took age as x, we took blood sugar as y, right? That means we need to find out what is the value of y for x equal to 35. This is basically what this example is asking you to find out. Find y when x equal to 35, right? So let me write down the formula, right? So we are predicting y equal to what when x equal to 35. That means this is a case of regression line of y on x, right? Because y is dependent on x. Now what is the formula for y on x? Y will appear first, byx, x minus x bar, which is also y minus y bar. What is byx? Covariance xy. What is independent x? So variance of x into x minus x bar. Okay. So here we have y bar is equal to 94.67, x bar is equal to 25.5, right? Variance of x is equal to 2.9167, and covariance of x comma y is equal to 8.1667, right? And the last term that we need is what is x? X is given as 35. So we got y bar, x bar, variance, covariance, and the particular value of x for which we need the value of y. So we will simply plot these values in this formula. So this implies y minus what is y bar, 94.67, right, equal to what is covariance. Covariance is 8.1667. What is variance of x? Variance of x is 2.9167 into what is x? X is 35, right, the value for which we want the value of y, minus what is x bar? X bar is 25.5. This implies y minus 94.67 is equal to, if you calculate this part, this will give us equal to, so within bracket, this covariance divided by variance of x into 35 minus mean of x. So this gives us 26.6. So this is 26.6. This is equal to y. If I move this to our right hand side, this is 26.6 plus 94.67. So this is equal to 94.67 plus 26.6, which is 121.27, right? So this is the value, that is the predicted value. That means for that particular person, the blood sugar in the year age 35 will be 121.27. So we have predicted this value using regression, right? So that is how we predict values. Now there is another example. Predict the value of x for y equal to 60 and value of y for x equal to 64. The same example, example number 2, the same data set. We have calculated that R in this case is 0.5. That means correlation exists and you can calculate it. So I leave this as an exercise to you. Please try this and find out the value of x for y equal to 60 and y for x equal to 64, right? So that is all about correlation and regression. So let me recap the entire idea. Correlation is association between two variables. Coefficient of correlation is the actual formula using which we calculate the amount of correlation. If it is positive, that means increase in one increases the other. If it is negative, then increase in one decreases the other. If it is 0, then there is no correlation, right? If it is exactly equal to -1, then the correlation is perfect negative. If it is exactly equal to 1, then the correlation is perfect positive. Fine. Now you can calculate correlation using the formula which is given by this one, covariance xy by multiplication of the standard deviations, right? So you can calculate correlations. We have calculated the correlations. Now calculation of correlation can also be done using the shortcut method, and we have found out that, interestingly here, if you make a new data set, then their correlation is exactly same as the original data set's correlation, right? So that means correlation is independent of change of scale and origin. That means if you shift the data right or left, or if you divide the data by a constant number, the correlation is unaffected, right? Now once you know how to calculate correlation, the next step obviously to use that information to predict future values, and that is called regression. Now regression has two different formulas. One is called y on x and one is called x on y. This one is y on x is calculate or use when you want to predict y from x. This one is used when you want to predict x from y, right? You cannot mix them up. And we have already shown how to calculate regression from this data, right? So that's all about regression and correlation. I hope you have understood, and I have given one example also to try. We have already calculated a correlation for this data set. I want you to try this to find out the regression or to estimate it. Now, one thing here is that in the original solution for this example, this data set, we have used shortcut method. Now, shortcut method will not be applicable or will not be helpful in regression, because for regression you will be needing variance of x, variance of y, and covariance of x and y, right? Fitting or this regression is not appropriate for shortcut method. So I suggest you to calculate the correlation between x and y by the conventional method. That means create a table x, y, x square, y square, and xy. So in a calculation of correlation, you need only these 5 columns. Calculate the total of all of them, find out x bar, find out y bar, find out variance of x, find out variance of y, and covariance xy, right? Then you can calculate the value of x and value of y for given values of y and x. That's all for this one. See you in the next one.